This is Chapter 3, Numerically Summarizing Data. This is a huge chapter. It's a very important part of the course that will be the majority of the exam because this is very important. You'll need to remember Chapter 3's information moving on into Chapters 6, 7, 8, 9, and 10. So it's a big part of the course and it will be the majority of the exam. So the first section in Chapter 3 is Section 3.1, the measures of central tendency. We're always worried about what's going on in the center of the data. So there's three characteristics of numerical or quantitative data that we like to look at. The first one is shape, the second one is center, and the third one is spread. So shape we talked about in Chapter 2, center we're going to talk about right now, and then spread is Section 3.2. So shape, center, and spread. You're going to hear me say that a lot as we get on into Chapters 8, 9, and 10. Shape, center, and spread. Center can mean different things for different data sets. There are three common measures of center. You might have heard of these before. The first one is mean. The second one is median. And the third one is mode. So mean is an average. We'll talk about how to get an average. Median is the middle. We'll talk about how to find the middle of a data set. And the last one is the most frequently occurring, which we don't cover too much, but I will go over how to find the mode and why it is important sometimes. All right, so let's start with the mean. The mean is an average. We're going to talk about how to get an average for a population, for when you have parameters, and how to get a mean for a sample when you have a statistic. So for a population parameter, we use Greek letters. And we're going to learn a few Greek letters, not too many in the course, but we are going to learn a few Greek letters along the way. The first one we're going to learn is for a population mean, and it is the Greek letter mu. M-U. It's a letter M with kind of curvy features. On the computer, it kind of looks like a letter U. They really shrink the little arms, and it looks more like a U. But it is a Greek letter M called mu. And the mu are all the data values, x1, x2, x3, however many data values you have. You add them all together, and you divide by capital letter N. And so this is written the sum of all the individual x values divided by N. And N is the population size. So we said lowercase n is the sample size, capital N is the population size. You might have seen this symbol before as well. This little kind of looks like a letter E to me. That is capital letter sigma. So again, a Greek letter, it's a capital letter sigma. And in mathematics, it means to sum. And you might have seen that in a different mathematics course. So we take the sum of all the x values and divide by the total. And that calculation gives us mu, which is the population mean. It is the same process for a sample. So if we want to get a sample mean, we use English letters. So we use English letters for samples, and that's true throughout the course. So if it's a Greek letter, it's a parameter. If it's an English letter, it's a statistic. And we'll see that a few more times throughout the course. So this we use, instead of mu, we use x with a bar on top of it. And we call it x bar. So it's a lowercase letter x with a straight horizontal line on top of it called x bar. And it's the same calculation, x1, x2, x3, however many you have, divided by lowercase n. Remember, lowercase n is the sample size. So capital N is the population size, lowercase n is the sample size. And we can also write that as the sum of each individual x value divided by lowercase n, the sample size. So to get an average, you add up all the values and divide by the total. Whether that total is coming from a population or a sample, it's the same procedure. If it's coming from a population, we use mu. If it's coming from a sample, we use x bar. All right, so let's do an example for this one. You will need your calculator throughout the rest of the course. So a TI-84 or a TI-83. I'm going to be showing everything on the brand new 84s, or the newer 84s, and the older calculators, 83s and 84s. So you might have a newer version of the calculator or an older, and I'll try to show you both every time so that you can kind of hopefully follow along with the calculator steps. Alright, so let's look at this example. We have 10 students in a calculus class. It says that this represents all 10 students in a calculus class. So because it says all, that means we're referring to the population. So we're going to treat these 10 students as the population. So the first thing I want you to do is get the population mean. So I want you to add up all the scores, 82, 77, add them all up, and divide by the total, which would be 10. So add them all up first, get that sum, then divide by 10. I'll give you a minute to do that. I'm going to work on it as well. When add them all up, you should get a total of 790. And then when you divide by 10, that should give you a population mean of 79. That means the class average for all the students is 79. To get a sample mean, instead of using all 10 scores, you would randomly select, and I'm going to say n equals 4 scores. So there's a lot of different ways we could randomly select. I just kind of want you to go down the list, and you can choose your favorite 4 numbers from this list or that list. It doesn't matter. Just pick 4. I'm just going to pick 4 scores here. So just randomly pick 4. Add those 4 up, the 4 you selected, and it truly doesn't matter. I just want you to pick 4. Add those 4 up and divide that total by 4. This is going to give you what we call a sample mean. So it's not the entire class, it was just 4 that you randomly chose. Add those up and divide by 4. Oh wow, mine ended up being the same number. It shouldn't be the same number, I just must have chosen very carefully. It was totally random. Mine ended up being the same, which is not normally the case. But your number should be different. Is usually, I'm not going to say it's always different, but it's usually different from the population. The 4 I chose happened to be the same, but normally when you randomly choose, yours might be a little smaller than 79, it might be a little bigger than 79. It's usually not exactly. My choices were just that way. So normally your sample mean compared to the population is usually a little different. It's usually not the same. I just want you to see the difference between a population mean, where you take everybody, or a sample when you just pick a few. And in your questions on your homework and on your tests, you'll see that it's either coming from a population or a sample. Most of the time we work with samples. Very rarely do we have the whole population. Alright, so mu and x bar again represent the same value. One's from a population, one's from a sample. Alright, let's talk about median. So median score is the middle value when the data are arranged from least to greatest. So the median score is the, oh, you cannot see that, sorry. Median score is the middle value when the data are arranged from least to greatest, or greatest to least, it doesn't matter, but they have to be in some sort of numerical order. So you find the middle score. If the number of data points is odd, like 3, 5, 7, 9, if that's your sample size, is odd, then the median is the middle value, which is an actual data point. If the number of data points is even, then the median is the average of the two middle values. So if I have 10 or 20 or 30 in my sample, then I find those middle two values and take an average, and it will not be an actual data value. So if you have an odd number of values, it is. If you have an even number, it is not. And I'm going to show you the difference with this example here. So let's find the median of the two data sets. So this first table, you have different song lengths, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 total. So the median will be one of those 9 values. Over here we have that same set of data, the 10 test scores, and because there's 10, the median will not be an actual data value. So to find the median, you want to list your scores from least to greatest. So it looks like the smallest number here is 179. I always mark them off as I go. The next smallest looks like 201. The next smallest is 206. The data sets are usually small, so you can do this fairly quickly. 208. Let's see, 217. 222, 240, 257, and 284. So least to greatest. And then you want to go along, and what I like to do, the way I find the middle, is I mark off the smallest and the biggest, and then the next smallest and the next biggest, bottom and top, until I get to the middle. So 217 is your median. Exactly the 217. So smallest and largest get knocked off until you find the exact middle value, and if it's an odd number of data points, in this case n equals 9, then the median is an actual data value. Let's do the same thing with the test scores. Let's list them least to greatest. It looks like the least is 62, and then we have 68. And then we have 71, 74, 77, then 82, 84, 88, 90, and 94. So least to greatest. Now we're going to work along to try to find the middle. In this case, our sample was 10, our population, just however many data points you have. And we're going to do the same thing, smallest, biggest, smallest, biggest, smallest, biggest. And what happens is we get down to 2 values. So we're going to take an average. We're going to do 77 plus 82 divided by 2, which I believe gives you 79.5. So in this example, the median is not an actual data value, it's the average of the middle two. So that's just an example of an odd number of data points and an even number of data points. So we can find averages by hand, we can find medians by hand. The calculator can do both of those things for you as well. So in the calculator, I'm going to show you the steps. The directions from the textbook are at the end of each section, I believe. So I pulled this straight from the textbook. Here are the steps. I believe the textbook is using the older version of the calculator, and I'm going to show you the same process with the newer version of the calculator. Alright, so, and you might want to make yourself a little calculator kind of list of how to do things as we go along through the chapters. You might just want to jot down the steps in the calculator. I'm going to watch the glare here. It's kind of hard with the newer calculator. So the first thing you want to do, whether you have an 83 or an 84, you're going to go to STAT, so S-T-A-T. We're going to use that button a lot. So I'm going to do both at the same time here. STAT, and then on both screens, and I'm sorry about the glare on this one. Make it a little darker. There we go. So the first option is Edit, and you're going to hit Enter for Edit. You should have L1, L2, L3, L1, L2, L3. If there's anything in L1, L2, or L3, you're going to go to the top. Where the L1 is highlighted, you're going to hit Clear and then Enter. Do not hit Delete. Delete deletes the list, and that's not good. So you go to the top, you push Clear, and then Enter. Do not push Delete, because it will delete your whole list. So you should have L1, L2, L3. If you do not have L1, please send me an email. I can show you how to fix that. It's too confusing over this video, but if you're missing L1 for any reason, let me know. So what we're going to do is we're going to use the test scores that we had before. We're going to put all of these scores in L1, and it does not matter what order. After each score, you're going to push Enter. So you're going to put the score in, hit Enter. Put the next score in, hit Enter. So it should be creating a list of the scores. I'm going to do this in both calculators real quick. So you're going to put all 10 scores in L1. L stands for list, so list 1. Just check your numbers as you go along. Again, the order doesn't matter, it's just getting the numbers correct. When you enter things in L1, your cursor, the black highlight, should be one below the last value. So if I have 10 values to enter, my cursor's on the 11th spot. Same thing here, I had 10 to enter, my cursor's on the 11th spot. Then you're going to push Stat again, so Stat. This time you're going to use the arrows to go over to Calculate, so use those arrows to go over to Calculate. And the first option you should see is 1 var stats. Var stands for variable, so 1 variable statistics. That's what we're going to choose. Hit Enter. If you have an older calculator, it just sits on the home screen, and you're just going to push Enter. If you have a newer calculator, it says List L1, which is what it should say. Frequency List says nothing. That should say nothing. If something's there, push Clear. And then we're going to go down to the Calculate and hit Enter. Alright, so it gives us the 1 var stats. It tells us that X bar is 79. It always assumes that everything we're doing is a sample. So even though we know those 10 students were the population mean, the calculator assumes sample. So unless you're told it's a population, we're going to assume it's a sample. So there's your X bar. The next values we're not going to worry about right now. I'll show you how what all those are later. You'll see little n is 10, that's your sample size. You're going to push the down arrow. If you see the down arrow here, push the down arrow. Keep pushing it until it doesn't let you push anymore. The min Q1 we're going to worry about at the end of chapter 3. The one we're looking for here is median, MED. So MED median, 79.5, which is what we got when we worked it by hand as well, 79.5. So again, the first number up at the top is your X bar, your mean. Go back up, and if you go down, MED is your median. So if you want to make a note of how we did that, you can do that at this time. Alright, I think I'm going to stop there for this video, and I'll continue with 3.1 in the next video.